Okay.
So you got 1 over 6. Is it because 2 minus 8 is 6?
8 minus 2, yes. So the whole thing is 6 wide. So this has got to be 1/6 tall to make the whole area 1, because it's all. Then it means all the probabilities add to be 1. I like it. There's that one problem in the homework that it's like 5.8 to 6.8. And how tall was that? 1. 1 over 1 is 1. So that's the one time the height would just be 1, is if the width is 1. Maybe get a little square. And the part C says, oh yeah, what's probably x equals 5? 0. Probably x equals something in a continuous distribution is 0. Or, if you want to say an iota, what's here? But it's basically 0. So that's part C.
Explain why is that like? I'm sure that's fine.
What'd you say?
Being an exact value in a continuous measurement is infinitely small. So
I love it. Kick ass. That's basically the idea of iota, sort of. Yeah, beautiful. So this is where I ask you this question, and I don't give a shit. You just got the formulas in the freaking book. You can just look them up and plug shit in. So you just got to plug stuff in. So part T says find the mean in the standard deviation. What's B and what's A?
2 and 8.
Yeah, 8 is B, 2 is A. So you just got to plug those suckers in. So the mean is 5. Standard deviation, let's see. Square root of 8 minus 2, 6 squared is 36, divided by 12 square root of 3 is like 1.7 something, or is it 1.5 something? I always forget that. No, it's good. Alright, square root of 3, right? Which is something. I think it's 1.7 something. 1.732. 1.732. Is everybody with me? Are you guys all right? We haven't gotten to the interesting part yet. Uniform distribution, easy. I feel comfortable saying that. It's got to be easy. If it isn't easy to do a problem like this, that's sort of bad right now. It should be easy finding area of a rectangle. What do you do? This is just a formula to plug shit into. Nobody's taken me up on my offer to show them where this came from. Yes? If you really wanted to, you could, but I already told you I'm not going to ask you any questions about it. Yeah. Which students sometimes take to mean that this is not worth anything, when in reality that's not what that means.
It's on the practice test. It says find me standard.
I know, so we just did
But
it.
it's not going to put that on the test.
Exactly. Yes. I love it. So was it in the homework? Yes. So on the practice test? Yeah. So it must mean it's something, but it's just, I don't have as much room on the test. So. Okay. So look at part, this is where things get interesting. Part E says, a sample of size 43, find the probability that the sample mean is between 4.4 and 4.7. So I love this question. So part E is the important, interesting question in this series. What happens when I take a sample of 43? What happens? Two things. What happens when I take a sample of 43? I'm asking about the sample mean, right? What happens? What changes? And what happens to the picture?
It has to be a normal distribution, right?
It becomes normal. So it's not uniform anymore, it becomes normal. That's number one. And why does it become normal, and normal enough at least? Greater than 30. Kick ass. Secondly, what else changes? What's the computational thing that changes? I take a sample and I ask about the sample mean. Standard deviation's got to change. So the point with that problem is, I don't give a shit that this came from a uniform. The minute I take a sample and ask about the sample mean, I've got to divide this by the square root of n. And then I can do work with it, right? So now the mean is still 5. The standard deviation is going to become 1.732 divided by the square root of 43, because that's my sample size, right? It's like 0.3 something. Maybe
0.263
263.
or 264. Sorry.
So again, let me say that again. I don't care where sigma came from. The minute I take a sample from that population I'm talking about, or the group I'm talking about, it's got to become this old one divided by square root of n, because this is good for individuals. What was this problem all about? Did I say? No, I just this is good for individual numbers. How spread out they are. Now I need to know how spread out 43, a group of 43 is from each other, because I'm talking about groups of 43 now. So what's the picture look like now? Yes, it's normal. Took a sample for it. So now it's this. So not doing anything with rectangles anymore for this one. What's in the middle? 5. And I want from 4.4 to 4.7. And so what am I going to create? Z-scores. And then I can look it up on the Z-score chart, because now I have a normal distribution. I can't do this shit anymore because it's not a big block anymore. So now you make 4.4 into a z-score. You got the mean and the standard deviation. Make 4.7 into a z-score. You look those up, get the area, subtract them. So that's why I love this problem. The mean and standard deviation came from somewhere we're not used to them coming from. Problem E doesn't give a shit about all that. So standard deviation changes. The mean stays the same. I make z-scores. Command. So how about 4.4? How would I make that into a z-score? 4.4 minus 5 divided by 0.264. It's like 2.4 something, maybe 2.3 something. I could be really wrong, so don't hesitate. 2.3 something. I don't know, the z-score for 4.4. Let's see.
Yeah, it's 2.27.
2.27. That's close. Yeah, 2.27. Then you look that up, get the area. Make this one into a z-score, you look that up, get the area, subtract those areas. Right? So because I took a sample large enough, it became normal, I can attack it with z-scores. I can't attack this thing with z-scores, can I? Because it's not normal. But when I took a sample of 43, it's normal. I can attack it with z-scores. Thank God, because I can't do these shapes like I could with this guy. This guy's easy shape, rectangles. This guy, oh shit. It's got a curvy side. I don't know. So for 4.7, must be like 1.2 something, 1 point something. 1.14. Yeah. Now it's just a normal problem, right? It's a look those z-scores up, get the area, subtract. Yeah. What's up? Oh, listen. Practice test. I don't give a shit. Get your own paper. Beautiful. Even a test, sometimes I'll bring some scrap paper and I'll say, you got no room on the test, put all your work on the scrap paper. Right? Yeah. I don't want to print out and staple, no. If I can fit it all on 2 sheets, I don't care how much space there is between them.
Or when we subtract it, do you do the subtraction of the 4.7 line first and then the 4.4?
Yeah, it's always big minus small. So your answer comes out positive for one thing. So this is too much. It's too much by exactly this much. So you take this one minus this one. Yeah. Just make sure your area doesn't come out negative. That should disturb you if it does. Like that negative area is like a black hole thing. When I try to grade that problem, I get sucked in.
Do we have any more quizzes?
Oh, hell yeah.
Like one more or two more?
One or two, something like that.
Sounds great.
Wow, somebody was asking me about the grades, so if I would have had time this morning, I would have printed out a grade sheet summary. Normally I do that after the second test, and I realized this is compressed, so I should have done it before now, but anytime you want to, you can come by the office and we can do some scenarios. Well, what if I turned in all the homework? What if I did corrections and got them all right? What would happen? So yeah, after the second test, I will give you everybody a sheet of grades, and I'll tell you what homework I think I'm missing, and I'll tell you what you need to make on the final to pass and all that kind of stuff.
So nice.
But that's the kind of stuff you can just come to the office and we can sit down and do. I'm not a fan of online anything, to be honest, online grades. I don't know if you guys realize, you know Canvas, right? You have teachers. When that first was installed, it wasn't doing the grade sheet correctly. Everybody's grades were higher than they were supposed to. I didn't want to be in a situation where I had to try to explain that to somebody who was passing, and I'm like, no, you're not really passing. If that mistake happens, I want it to be because of me, not because of some stupid program trying to figure out what I want. Anyway, sorry, a little rant. I do those a lot nowadays. So that's one reason why I don't use Canvas. Also because it sucks. That's another reason. Yeah. I am about to. Just want to give people a chance to see if anybody tried a problem that they have a question about or something, or give you guys a chance to do something before I give you the answers. Because we're human, we're gonna glance at that answer key too early if I give it to you too soon. But I mean, I might as well just give it to you, right? Oh, good. Yeah, tomorrow I'm gonna be out this at 7. So you guys, like I can't even get there your normal time. So,
What is your normal hours? So I tried to go in today, but the door was locked. I was just like,
what time are you there?
7:40.
Oh, well, it starts at 7:45.
Makes sense.
So right at 7:45, I go out and then lock it. But you can knock on it if it's close to the time, and I'll let you in if I want to.
I was just like, oh, I must have got the office hours wrong.
I'm sorry, man.
It really wasn't that important because you end up doing the problem I wanted to do anyway, so it's took all
Worked out.
day, but it's okay.
I'm with you. Sorry, man.
That's all it is. Like, I got the answer, and that's all really all that matters. That's not gonna be on the test, so really.
Oh, there you go. That really makes it better. Does anybody remember the question I already told you will definitely be on the test?
I don't remember. What question's definitely gonna be on the test?
The one beside that one.
What does the z-score tell you? Oh,
The
so
number-
what does the z-score tell you?
The number of standard deviations away from the mean.
No percent. The number of standard deviations from the mean to that data point.
Okay.
So what if I say, what would a z-score of 1.29 tell you about a data point?
It's 1.9.
That data point is 1.29 standard deviations away from the mean. Or you can even be better and say above the mean, but I'm not going to take points off if you don't say why above, because it's positive. So if I had a negative one, you can say below the mean, little tear comes out. I got about 50% of people get it right, even though I tell you ahead of time that that question in one of those two forms will be on the test.
Wait, which?
So either I'll say, what does the z-score tell you about a data point? Or I'll say, what would a z-score of negative 0.87 tell you about that data point? Don't tell me a shit about areas. Does a z-score tell you areas? No. Where do you look to find areas? On the chart. And you can only use the chart if it's normal. I didn't say shit about either of those things, right? What does a z-score by itself tell you? The number of standard deviations away from the mean to that data point. I'll take some variations on that course. I don't want you necessarily, I know some of you guys will just memorize that wording, but I would really love it if you just understood the idea.
That's right. So then you give me -2. I'm like, oh.
I know.
True. It is true.
If your explanation does not contain the correct concept, I'm going to have to take points off.
Well, it does, but I just like leave little words out. You're just like, what is this? Big question mark. I'm like, oh, okay.
But that, so I really want, I know it feels like sometimes I arbitrarily take points off. Really make sure why I do that. I only take points off if there's some important piece of something missing, or I feel like you explained it counter to what it really is supposed to mean or something. So if you're not sure why I took points off, you've got to ask me. Yeah.
I should probably dig in.
I don't just go, man, I haven't taken points off in a while. Let me take some points off.
May I see that pile so I can grab my test out?
Oh, yeah, go ahead.
Question we were just doing, did you just answer the 0.24 or?
Yeah, I didn't finish it out. So if you look up 1 point, this should be negative 1.14, right?
Yeah.
So if you look up negative 1.14, what area do you get?
Hi. Are you okay? How are you?
And if you look up negative 2.27,
Yeah.
oh, 116. Now just subtract those, and that's the answer.
And told
Oh, I didn't put it on there?
today, and then today I'm like,
That's what I thought I did one on Thursday, and I was like, I feel pretty good. And then I started doing some last night. and I was
Oh,
like,
I just
wait a
stopped
minute.
it. I got tired.
Yeah.
I'm glad I did it up there then.
So this is because I left out the sum and then like which value.
Wait, did he give us our test?
Yes.
Okay.
Yeah.
Yeah, none of the p of x is equal to 1.
Okay.
Right.
Or
I know it's
quizzes.
it's-
Yeah, our
right.
quizzes.
Yeah, yeah.
It's just
Our
yeah,
tests.
okay.
Okay, cool.
No, it's like where I leave out like a little thing, so I'm like
But
concentrating
see,
on the test as a whole.
because that's
and I'm
related
like,
to an
oh.
idea that's important, and I
Right.
know sometimes
When
you
do
know
we
the
have
idea, but it's also important to be able to communicate ideas.
Test
Yeah, so I
corrections.
I know
we
it can be
have up
frustrating,
until the
but
No, I was just like, man, I knew he knew what I meant,
Oh,
but
test
like,
Yeah.
But it is that
For quiz
communication
corrections up
component.
until
Right.
Yeah, yeah.
I understand.
test, so
Good.
tomorrow.
because I got it right on the text question, because I like wrote, because I was knew what he meant. I'm
And
pretty
see, it's
sure.
always better to make the mistake on a quiz because they count less.
Yeah.
So, yeah.
Yeah, but I've done good on the test.
Sure.
When you're from the test, I got 96.
Oh, the first test?
The
The test average is like 50%, is that right? Whatever it says on the syllabus?
I think it's like 50%.
So then each test is 25%.
I'm like,
Yeah.
oh,
okay. Yep.
I don't know. I might do it today just because, like, I need practice. Yeah.
What I get wrong on this?
Oh, standard deviation always has to go out at least